Today, we're going to dive into one of the most incredible ideas in all of technology, AI that doesn't just calculate, it actually creates. We're talking about AI that can dream up art, music, and even people who have never existed. So, how in the world did we teach a machine to have an imagination? Let's get into it.
I mean, just stop and think about that for a second. What if a computer could just invent a face, or a painting, or a piece of music that's totally new? It sounds like something straight out of a sci-fi movie, right? But it's very, very real, and the technology behind it is called a Generative Adversarial Network, or a GAN for short. So how does this magic trick work? Well, the best way to think about it is to imagine you have an expert art forger and a world-class art critic. The forger, we'll call that the generator, is constantly trying to create fake masterpieces. And the critic, that's the discriminator, is trying to spot them. It's this nonstop competition, this cat and mouse game, that forces both of them to get unbelievably good at their jobs. The forger gets so good, its fakes become almost indistinguishable from the real thing.
But this amazing tech didn't just pop into existence fully formed. Nope. To really get it, we've got to go back to the beginning, back to the original recipe, the first brilliant but, as we'll see, pretty flawed idea that kicked this whole thing off. And here it is, the vanilla GAN. This was the original blueprint, kind of like the Model T of creative AI. It used some of the simplest neural networks out there at the time and a pretty basic training method. Now, it was revolutionary because it proved the concept could actually work, but yeah, it was far from perfect. And just like a lot of first drafts, this brilliant idea hit a couple of pretty big snags right out of the gate. There were some major flaws that researchers had to figure out how to solve. And here are the two big ones. First, something called mode collapse. Imagine our art forger creates one fake that happens to fool the critic. Well, the forger might just get lazy and paint that same exact fake over and over again. Not very creative, right? The other problem was unstable training. This is when the forger and the critic just stop learning from each other, and the whole improvement process completely breaks down. Okay, so we've got our problems. The next big chapter in this story was all about solving them. It was about gaining more control over what the AI creates, and just as importantly, seriously upping the quality. And this was the fundamental question. The original GAN would just create something, a random blurry image. But what if you wanted it to create something specific, like a picture of a car or a dog? How do you give it directions? The answer was beautifully simple. It's called a conditional GAN, or CGAN, and the idea is you just give both the forger and the critic a little hint, a label like the word cat. So now the generator isn't just making a random image, it knows its job is to make a cat. And the discriminator isn't just looking for any old fake, it's specifically checking, is this a convincing fake cat? That one little change was a game changer. It gave developers control. All right, so problem one is solved. We have control now. But the quality of the images still wasn't quite there. They were often blurry and low res, so the next big challenge was, how do we make them look genuinely real? The next huge leap forward came with a smarter architecture, the Deep Convolutional GAN, or DCGAN. The key insight was to swap out those simple generic neural networks for something way more specialized for images, convolutional neural networks, or CNNs. You can think of CNNs as having a kind of built-in vision. They're designed to understand things like edges, textures, and shapes. And making that one architectural change, well, it made a world of difference, leading to much higher quality and more stable images. So, with control and quality getting better and better, the goalposts moved. The next frontier was a huge one, pushing the absolute limits to achieve true, undeniable photorealism.
Yeah, we weren't just talking about making a good fake anymore. The new mission was to create images so crisp, so detailed, that you literally could not tell them apart from a high-resolution photograph. The bar was set incredibly high.
So how do you possibly do that? Well, one super clever approach is the Laplacian pyramid GAN, or LAPGAN. Its strategy is simple. Don't try to create a masterpiece all at once. Instead, build it up in layers. Imagine an artist making a very rough, blurry sketch first. Then they add a new layer with more detail. Then another with even finer textures. That's what LAPGAN does, using multiple generator critic teams, each one responsible for adding a new layer of detail, building the image up from a fuzzy blob into a stunning high-res photo. Okay, so LAPGANs are fantastic for creating things from scratch, but that leads to a different kind of problem.
What if you already have a picture, but it's tiny, or blurry, or it's super pixelated?
And that's exactly where the super resolution GAN, or SRGAN, comes in to save the day. Its entire purpose in life is to take a low-quality image and intelligently dream up the missing details to make it look sharp and realistic. It's basically like an AI photo restoration artist that can take a blurry old photo and make it look like it was taken yesterday.
So we've gone on this incredible journey, right? From a simple idea all the way to models that can achieve unbelievable realism. But I want to make sure you know, this isn't just theory. Let's take a quick peek at how these things are actually put together in the real world.
You know, it's really easy to hear all this and think it's some kind of abstract, far-off science fiction. But it's not. Real developers right now are building these incredible systems using powerful tools that are surprisingly accessible. And here are the basic ingredients. It's like a recipe. You start with a powerful coding framework like PyTorch to do the heavy lifting. Then, you need a ton of data for it to learn from. A huge data set like CIFAR-10, which has thousands and thousands of real pictures. And you build it all using one of these smart deep neural network architectures we've been talking about. And, you know, at the end of the day, after all that complexity, it really all comes back to this one simple idea. That whole complicated dance between the generator and the discriminator, it's all just to learn the patterns in real-world images so well that it can create brand new, totally convincing ones all on its own. So that's the journey. We've seen how a machine can learn to be an artist, evolving from a simple, flawed concept into something capable of generating true photorealism. And it kind of leaves us with this one big, fascinating question to think about. If an AI can create, what does that say about what it means to be creative in the first place?